Good morning, everyone. I would like to thank all the organizers at the Grain School for the opportunity to be able to talk this morning in this interesting forum. Today, I would like to share some knowledge and research about nixtamalization and the impact in nutrition and health. So as we have been hearing before, Mexico is the center of origin of maize, and we have about 59 native maize races in the country. There is a large diversity, not only because all this diversity of races, but also there is a large diversity inside each race. About 63% of these different type of maize are being used for nixtamalization. And, we know that more than 600 food products are prepared with maize, and about half of them are actually based on the nixtamalization technique. The diversity of this maize and all these races that we are able to find, it is also reflected in the diversity of the compounds that are part of the kernels. So it is a big range depending on the type of maize and also some other characteristics or some other factors that are influencing the concentration of certain compounds. So as we have seen, the whole kernel of wheat or rye, this is the whole kernel of maize, where we also have three main components: the endosperm, that in the case of maize, we have soft endosperm and floury endosperm, and it's mainly composed by starch proteins. And in case of the yellow maize, it also contains the carotenoids that give the yellow color to those kernels. The endosperm also contains vitamin E and resistant starch. The component is the germ of the embryo that is also rich in lipids, mineral, antioxidants, and vitamins. And the outer layer or pericarp is rich in minerals like iron and zinc, dietary fiber, phenolics, and in the case of blue maize is where most of the pigments like anthocyanins or flavonoids are present. And between the pericarp and the endosperm, we find a very thin layer of cells that is called the aileron cell layer, and it's actually very important and rich in minerals and also some of the compounds, especially for blue maize and red maize. So the concentration of these compounds and actually the presence of some of these compounds are given by factors. The main one or the first one, the genetic characteristics or the genetic factors, meaning that depending on the variety, we will have some maize that are, or some kernels that are white, yellow, blue, red, etc., but also that have different concentrations or different proportion of these structures and different concentration of these compounds. Agronomy, how we grow the crop, is also really important to determine the concentration of the different nutrients in the kernel. Then the post-harvest management is very important as well, because some of these compounds can be lost during the post-harvest handling. That is the case, for instance, of the carotenoids that with the time tend to be reduced in the kernels, and even worse when we mill it and we store the flour. So all these characteristics and the interaction, especially of the genetic and the agroenvironment, are going to determine the end use and the nutritional quality of the kernels. So how can we increase the nutritional benefits of maize kernels? Well, there are different options, and all of them are important and complementary. Of course, I mean, as we have been hearing, the use of the diversity of maize is really a gift that we can explore. And in that case, we talk about blue maize, carotenoids in yellow maize, and also popcorn, pozole, or humini. There are also some varieties that have been bred to increase the concentration of certain compounds like biofortified maize, where we find maize with high protein quality, maize with provitamin A carotenoids, and maize with high concentration of zinc. Processing is also another way to increase the nutritional benefits of the kernels, especially if we use whole kernels to prepare our final product. Nixtamalization is another ancient technique that is being used largely in Mexico and Central America to generate many food products with increased nutritional benefits and fermentation. And of course, we have heard about functional food, and in this case, we can include or take in account blending the maize flour with legumes or other grains, or actually use a whole grain maize flour. So talking about nixtamalization, it is actually known as alkaline cooking or lime cooking. We can find that one in the literature and the references as those with those names. Nixtamalization is actually the original name, and it's a conversion from the Spanish word, which is nixtamalización. Which are the main ingredients of nixtamalization? So actually there are only 3 ingredients. First, corn or maize, lime, which is normally calcium hydroxide or calcium oxide, and water. In the case of the maize, some characteristics are important, are going to affect the specific steps of the process. So characteristics like color of the kernel size, and hardness. And in the case of lime, depending on the area in the country, and depending actually on the uses of the final product, the concentration of the calcium hydroxide can vary between 0.5 to 3%. So what is the process? So first of all, we wash the kernels, the whole kernels. Then we cook them with the calcium hydroxide, as I mentioned, depending on the region or depending on the uses and the customs. We use between 0.5 to 3% of calcium hydroxide. So we add it to the water, and we cook the kernels between 25 to 40 minutes. The time of cooking actually depends on the kernel hardness. Once the kernel is soft, and one of the tests is actually taking one kernel and see if you can easily remove the pericarp, yeah, and it's actually a little bit soft. In that case, in that moment, we stop the fire and we let that solution steep for around 16 hours. Also mentioning that the steeping process actually, the time of the steeping process actually varies again depending on the region. In some parts of the country, they steep only for 30 minutes, and in some others, and actually in the majority, is overnight process. The day after, or after the steeping process, the kernels are drained and washed, and again, the washing can be really gentle, or can be a little bit stronger, and we remove a little bit more of pericarp. But in general, at the end, the kernels that we are going to mill are actually partially whole or partially entire, in the sense that we have the germ, we have some part of the pericarp, and we have the endosperm. Then we proceed to mill the kernels, and this can be at the household level, or actually at the semi-industrial level. Most common that we use is actually volcanic stones that are producing some heat because of the friction of these two volcanic stones, and part of the cooking is actually occurring well during this process. The advantage of nixtamalization is that the dough that we produce is through, of course, a wet milling process, And this dough can be preserved for more than 6 to 8 hours at room temperature. And once we produce the tortilla, which is the most common product, this one can be maintained for around 2 days at room temperature or more than a week under refrigeration. So as mentioned before, the specific steps of nixtamalization depends on grain color, grain hardness, and grain size. And actually in Mexico, we have a specific norm that regulates the grain that is being commercialized for nixtamalization. And in that norm, we have some ranges of these different traits in order to classify the kernels and recommend the best ones for the different processes. In terms of the kernel hardness or grain hardness, it is important that most of the maize processed by nixtamalization is actually using intermediate kernel hardness. What does mean? That there is the same proportion of vitreous endosperm or the hard endosperm and the soft endosperm. And why is this? We will see it later, but actually a higher concentration of the soft endosperm will have different processing steps and also will have a different characteristics of the dough and the final, the quality of the tortillas. But well, the other important ingredient of nixtamalization, as mentioned before, is the calcium hydroxide, the lime that we are using. And we can use calcium hydroxide, calcium oxide, and there are other sources of salts that are being proposed. And in some areas they are using it, but the most common one is calcium hydroxide, which is what is also very important is that it is food grade. And again, the same, there is a norm here in Mexico that people have to fulfill in order to ensure the food grade quality of the lime, especially with specific limits in the concentration of metal minerals like lead, fluor, or arsenic. In Mexico, we can talk about 3 different levels of nixtamalization. The biggest one or the most popular one is the wet milling level, or what we call the tortillerias, which are more than 60,000 around the country, and is a combination of the traditional process, because the nixtamalization itself is, as described before, is very traditional, but then it is somehow a more high throughput than the household level nixtamalization, in the sense that there is a specific machinery for the nixtamalization and a specific equipment also for the tortillas baking. The other level of nixtamalization is what we call the nixtamalized flour industry, which is also growing a lot. And we have about 6 brands in the country that produce more, with more than 30 factories around the country, and they actually use large quantities of maize for the conversion of the kernels to nixtamalized flour. The process is also the same. The big difference is that once you have the dough, which is wet, they dehydrate that dough and is subject of other type of millings in order to have the different characteristics of the flour. And the other level is the household. In most of the urban areas, is not really common. In the rural areas, people are still doing the nixtamalization at home and then taking the nixtamalized kernels for milling in local shops in the towns. As mentioned before, the different process of nixtamalization depend on uses and customs, type of maize that people are using, the final product preparation, and the costs. Different changes of the in the kernel during the nixtamalization. First, well, there is a grain swelling because they are immersed in water. We lost some solids because, as mentioned before, some parts of the pericarp are actually being removed while they are in the steeping process or during the washing process. There is partial gelatinization of the starch, mainly due to the incorporation of the water to the maize kernels, and actually the temperature of the cook kernels. And of course, there are some nutritional changes that contributes to the high benefit of this process. In the case of the calcium hydroxide, the role of this compound is actually helping to break some bonds in the starch molecules and other compounds, and it facilitates the water penetration and the starch gelatinization inside the kernels. As mentioned before, the cooking time depends on the kernel hardness, and there is actually some guidance depending of the kernel hardness, but normally, as commented, normally we use intermediate kernel hardness, which normally takes between 35 to 40 minutes to cook in the process. Starch gelatinization occurs between 57 to 58 degrees. And when we complete the cooking, so after the 35 minutes, only 20% of the starch is being gelatinized. The remaining gelatinization occurs during the steeping process, and there is water absorption by the starch granules that occurs during the milling and the preparation or the cooking of the tortilla. It could be cooked or it could be fried. What is very important is to ensure the appropriate gelatinization of the starch, because if we have an incomplete gelatinization, the dough is not cohesive, difficult to mold, and tortillas are hard and easy to break in case you can do it. You can make the tortillas. If there is too much gelatinization, the dough is sticky and is gummy, you cannot really manipulate it. The dough doesn't have the cohesivity that is required to form the tortilla, and again, the tortillas, if you can make them, can be very easy to break. Which are the nutritional benefits of the nixtamalization? Well, the first one is actually the contribution to reduce pellagra disease, and this is actually due to the increase of the niacin or vitamin B3 bioavailability. We also have an increase in the calcium intake due to the absorption of the calcium by the kernels during the steeping process. Nixtamalization serves as a source of dietary fiber because, as mentioned, we partially lose some solids, but still we have whole kernels that are being milled and finally are being part of the final product. There is a slight decrease in the levels of phytic acid that, as we know, is an inhibitor of the iron and zinc absorption, of mineral absorption in general. There is also an increase in the calcium and phosphorus ratio, which makes the tortilla nutritionally similar to milk. And because of the washing process and actually the high pH of the cooked kernels, there is also a significant reduction of mycotoxins in the kernels. When we talk about the retention of the nutrients in the tortillas, I mean, there is a different retention in the of the nutrients in the process, but talking only about the tortillas, in the case of anthocyanins, we estimate less than 30% retention because anthocyanins are actually soluble in water and you lose a lot during the steeping process, but still you have about 30% in the final product. Calcium, of course, you increase the uptake of calcium, and depending on how much you put of calcium hydroxide, then you will have higher concentration of calcium, up to 3,000% more than what you have. There is also an increase, or actually a maintain of or retention of essential amino acids like tryptophan, lysine, and methionine between 80 to 100% is being retained in the tortilla. Protein is between 85 to 90%. Provitamin A carotenoids is also highly retained because you grind the kernels as a whole, so you don't lose much of the carotenoids in the process. And in the case of zinc, there is also a high retention. So at the end, you don't lose much of the important nutrients, and actually you gain some, like calcium, as being part of the ingredients incorporated to the nixtamalization process. So just to illustrate, in the graph in the left side, it's actually how the calcium content is increasing through the steeping process. So the more hours you steep the kernels, the higher will be the concentration of the calcium, and that's why we estimated around 12 to 16 hours steeping process to be the most recommendable one. And also for convenience is the one that is that people are using the most here in Mexico. Provitamin A retention is also highly retained in tortilla, in totopos, and in other product that is called tamales. And all of them are derived from nixtamalized kernels. In the case of fiber, it really depends on the method. And being the traditional nixtamalization reported, although there is a big range or a big difference between the different studies being published, but nevertheless, traditional nixtamalization actually contributes more in terms of the fiber. When we talk about blue maize, which is actually highly, I mean, he's increasing in some parts of the United States. Well, blue maize is rich in anthocyanins. Those compounds, as mentioned before, are soluble in water, and most of those compounds are actually present in pericarp or aleurone layer. The most common anthocyanins in blue maize are actually cyanidin 3-glucoside, pelargonidin 3-glucoside, and pionidin 3-glucoside, but there are more than 20 different anthocyanins that you can find in the different races of blue maize and also in some of the red ones. Anthocyanins can be lost during the nixtamalization process, as mentioned before. Around 70% is being retained in tortillas or actually in the nixtamal, in the cooked process, in the cooked kernels. And you lose more when you produce the chips, when you fry the tortillas. You lose around 75%. Atole, which is a drink prepared of nixtamalized kernels, have losses of around 75 to 80%. However, there are known nutritional properties of blue tortillas. Some of them are actually being validated in animal models, and anti-carcinogenic properties, antioxidant and anti-inflammatory properties have actually found in the blue tortillas, and is of course given by the concentration of anthocyanins. This is actually some of the work that we have been doing, but also there is an important researcher here in Mexico, Luis Arturo Bello, who has worked a lot with the nixtamalization of blue maize, and it is already known that tortillas derived from blue or red maize are actually lower in glycemic index and are high in resistant starch. So actually contribute much better to the nutritional quality of the product. So nevertheless, there is still a lot of problems, diet-related problems in the Mexican population and actually around the world, with an increase on obesity and overweight, and as well an increase or actually high levels of malnutrition worldwide. So in the case of Mexico, for instance, out of the 10 reasons for death in Mexico, around 4 or 5 are actually related to the diet. So like high fasting plasma glucose, high body mass index, dietary risk, high blood pressure, etc. So there is still a lot to do. In the graph, in the inferior part of the screen, you can see the intake of food groups by Mexican adults related to the health reference diet of the Eat Lancet report. The blue bar is actually the reference, and the others are the intake by Mexican adults, urban population, rural population, and indigenous populations. So I'm just highlighting here the intakes of high fiber grains. And although we consume a lot of nixtamalized maize products, there is actually a room to improve our intake of fiber, especially by the Mexican adults in the urban population. And some whole grain maize food products that we should increase our intake is actually things like pinole, tortillas, popcorn, roasted or boiled fresh maize. So something to consider in our diet. Here, just some references that in case you want to um, learn or read more about nixtamalization and maize diversity. And with this, I would like to thank for your interest and for your attention, and I will be happy to receive any feedback. Thank you very much.